Good morning, everyone. I'm Robin Gaster. I'm Research Director for the Center on Clean Energy Innovation at ITIF, and I'd like to welcome you to this event on industrial decarbonization and, sorry, I was getting ahead of the administration, on industrial decarbonization and US manufacturing competitiveness. ITIF has, as many of you know, been focused on innovation and competitiveness for many years, and there's now an intersection between that and our work on climate. We are fortunate to be hearing from the experts who will be speaking today. We'll be hearing later from Representative Chrissy Houlihan and from our distinguished panelists, who I'll introduce later. But I'd like to start by welcoming Dr. Avi Schultz. Dr. Schultz is Director of DOE's Industrial Efficiency and Decarbonization Office and leads the administration's strategy to accelerate innovation and to encourage the adoption of cost-efficient technologies for eliminating industrial emissions. He was previously manager of the Concentrated Solar Power Program at DOE and has a degree in chemistry, a PhD in chemistry from Northwestern University. Dr. Schultz, please.
Thank you very much, Robin, and thank you very much, of course, to ITIF for helping to set up and organize this event. Since the Industrial Revolution in the 19th century, the industrial sector has been the foundation of America's economic growth and prosperity. Today, the industrial sector creates more than 21 million stable, well-paying jobs in American communities, and is a critical driver of national productivity, contributing $4.8 trillion to the US economy. However, these economic engines have also given rise to decades worth of industrial pollutants in our air and water. Today's communities, particularly those most vulnerable, are facing adverse health effects like cancer, asthma, and environmental degradation from decades of industrial pollutants. The industrial sector is also responsible for 38% of carbon emissions in the US. And this number is only projected to increase in the future as demand for industrial products grows. Now, we are on the edge of the next major industrial transformation. Industry is facing several growing competitive pressures. Investors and financial regulators are increasing focus on emissions footprints. Governments are developing emissions-based trade adjustments and procurement specifications, and downstream demand for low-carbon products is emerging. And there is a growing need to create sustainable, secure, and resilient supply chains for energy, materials, and product supply chains to strengthen our national security. This landscape provides a once-in-a-generation opportunity to grow the US industrial sector, create good-paying jobs for Americans across the country, and sharpen our competitive edge and national security globally. It's a decisive moment to ensure that negative impacts of the industrial sector no longer rise alongside the sector's growth and the benefits it brings to our economy and communities. Tackling these emission levels with cost-competitive solutions will be challenging. We're fundamentally reimagining a sector that has been optimized over hundreds of years with unique technologies and processes spanning many different subsectors. And it must be done at a pace and a scale that we've never seen before. This will require investments at every stage of the innovation pipeline, from fundamental science to applied research and development to demonstrations and full-scale deployment. Industrial modernization will need to ensure US industry remains domestically and globally competitive. It needs to do so while feeding the innovation economy to create those advanced, environmentally just technologies, skilled and diverse workforces, and encourage continued onshoring of manufacturing. For DOE, Department of Energy, this is an all-hands-on-deck effort. DOE's Industrial Decarbonization Commercial Liftoff Report, which we released last year, estimated that we can cut up to 40% of emissions with cost-effective technologies today. That leaves over 60% of emissions reductions that need to come from innovative solutions that are still in the earliest phases of the innovation pipeline and are not currently market ready. Transformational market ready technologies begin with fundamental science and applied research and development. DOE's Office of Science is working on foundational science and discovery, while our applied R&D offices, including the Office of Energy Efficiency and Renewable Energy, which my office is part of, as well as the Office of Fossil Energy and Carbon Management, are working to further these ideas through research, development, and pilot scale demonstrations. Together, through our program that we call Technologies for Industrial Emissions Reduction Development, or TIERD, these offices are supporting the advancement of today's most promising ideas to become tomorrow's most impactful technologies. Because of the bipartisan infrastructure law and the Inflation Reduction Act that have been passed over the last several years, DOE is also directly funding demonstration and deployment, investing billions of dollars in large-scale demonstration and deployment of clean energy technologies. DOE's Office of Clean Energy Demonstrations, $6 billion, is the single largest investment in industrial decarbonization in American history. Additionally, DOE's Office of Manufacturing and Energy Supply Chains is helping the IRS implement the 48C investment tax credit. And this past March, the IRS allocated approximately $4 billion of 48C credits for over 100 projects across 35 states, with approximately $1.5 billion allocated to projects in designated energy communities. That office also leads over $1 billion in grants for small and medium-sized manufacturers. Additionally, through DOE's Industrial Technology Innovation Advisory Committee, we're working with several groups, including public and private entities, nonprofit organizations, labor groups, small and large-scale industry, and more, so that we have a range of perspectives to help us address industrial emissions and advance innovative technologies in the private sector. This strategy was designed to be private sector-led, government-enabled. We have given businesses all the tools they need to keep building a clean energy economy here in America for years to come. To date, DOE has already committed nearly $80 billion to nearly 2,000 clean energy projects across the country. In turn, the private sector has matched that $80 billion with another $104 billion of their own investment. In just the 2 years since the Inflation Reduction Act was passed, the United States has invested more than $500 billion in clean energy and infrastructure. And most of that is from businesses and consumers. For every dollar the federal government invested, they have invested $6. At the Industrial Efficiency and Decarbonization Office, or IEDO, as we call it, we're laser focused on developing the technologies needed to decrease emissions and increase competitiveness across US industry. We're working to accelerate the innovation and adoption of cost-effective technologies that eliminate greenhouse gas emissions across the US industrial sector. We're investing in both sector-specific technology solutions and cross-cutting technologies that can be applied across the industrial sector. We're focusing on core, hard-to-decarbonize industries, iron and steel, cement and concrete, chemicals, forest products, and food and beverage. And we're also providing manufacturers with technical assistance tools, best practices, assessments, and training resources to overcome barriers for technology implementation and meet energy goals. In the last 2 years, IEDO has already invested more than $500 million in R&D projects to advance innovative technologies that will be required to decarbonize our industrial sector. Our investments span both industry-specific technologies to decarbonize our highest emitting sectors, as well as sector-agnostic technologies like low-carbon fuels and on-site energy that can be deployed across industry. And we continue to invest in public-private partnership and barrier busting, such as through our flagship voluntary programs, Better Plants and the Better Climate Challenge. We work with over 600 leading industrial and commercial organizations to drive investment in energy efficiency and other clean technologies and practices, and to de-risk and demonstrate successful strategies and pathways. More than 200 organizations have volunteered to partner with us in the Better Climate Challenge, which we launched in 2021. And on average, these partners are currently reducing greenhouse gas emissions by more than 20%. We've also launched 2 new energy earthshots that span across the Department of Energy, focused on industrial decarbonization. Our industrial heat shot, focused on reducing the emissions associated with providing process heating to industrial processes, as well as our clean fuels and product shop, which is focused on reducing the emissions associated with the carbon feedstocks that are input into our chemicals and products and fuels supply chains. We are investing over $100 million in new national lab centers of excellence and technology de-risking capabilities to work hand in hand with industry to tackle the hardest challenges. For example, we recently announced $9 million for a cement and concrete center of excellence to enable the safe and rapid development and adoption of low carbon cement and concrete technology solutions, including developing tools to predict performance in different service environments. We also launched DOE's newest Manufacturing USA Institute, the Electrified Processes for Industries Without Carbon, or EPICS Institute, a $70 million investment in advancing cost-competitive industrial heat decarbonization technologies using electrification. Additionally, our Technical Assistance and Workforce Development Program has launched our on-site energy program and our technical assistance partnerships. DOE's Industrial Decarbonization Roadmap, which we released slightly more than 2 years ago, laid out DOE's strategic foundation of key strategies and sectors to prioritize for industrial transformation, and it identified research, development, and demonstration investment opportunities and actionable steps industry can take to reduce emissions across the nation's most energy-intensive sectors. Our Pathways to Commercial Liftoff report, which I mentioned earlier, analyzed the investment scale needed to reach our goals in the near term. Now, we are building on the strong foundation of those reports to chart out a detailed course of how we're going to pursue pathways to industrial decarbonization in parallel, and how we will work across the federal government and private sector to do it. This new Industrial Pathways Vision Study, which we first started talking about at a workshop in May of this year, is going to chart, this new vision study is centered on providing solution options. There's no single pathway to decarbonization that will work for any single industrial subsector. This study is informed by 2 years of national laboratory modeling, numerous stakeholder convenings, and a recent request for information we released this summer. We have identified multiple cost-effective and industry-specific strategic pathway archetypes to achieve a thriving and clean U.S. industrial sector. This strategy will go into detail on decision points and primary drivers that shape each pathway per industry, including regional considerations, and the timing and information needed for decision-making, as well as going into detail on the major sources of uncertainty as we execute these pathways. Similarities and differences in technologies and solutions across the major pathways, including investments that can be made in parallel, and no-regret strategies versus areas of risk for stranded assets as we go forward. This report will quantify the technological, economic, societal, and environmental and health impacts associated with the scale and pace of an industrial transformation. And it will go into detail on the barriers to successful development and accelerated deployment of the key technologies and solutions identified in each pathway, and the strategies to overcome these challenges and barriers. For example, using iron and steel as an example, our pathways analysis found that there are 2 primary pathways to near zero emissions by 2050. The first, primarily focused on integrated mills with carbon capture and sequestration retrofits, continues to use the blast furnace, basic oxygen furnace that we've been using for more than 100 years and relies heavily on carbon capture and storage. Alternatively, a parallel pathway to decarbonization focuses on scaling up direct reduced iron made with hydrogen, which focuses on hydrogen as a reducing agent and as a fuel with a diminished role for carbon capture and sequestration. Because we don't know what the future holds, these pathways vary significantly and show 2 very different routes for achieving our goals, depending on our domestic iron making capacity and the uptake of hydrogen-ready direct reduced iron in the future. This strategy will analyze factors beyond the plant bounds, from the economics of new technology adoption to the communities who've suffered the most from industrial pollution. Refining this will ensure that we're on the right path to competitive, clean energy manufacturing, good paying jobs, and protecting our communities. This vision study, along with our substantial investments in technology development, will help advance towards the goals already set by the private sector. Industry is investing their capital and their technical know-how alongside the DOE to meet demand for low emissions products in a sustainable and cost-effective manner. Thank you.
Thank you, Dr. Schultz. If you'll hang around for some questions, I believe Representative Houlihan is here, and I'd like to welcome her to the podium.
Good morning, I think it still is. I don't even know what day of the week it is, but it's nice to be with you all today. And thank you very much to ITIF for having us and for convening this really important panel. And thank you all in the audience as well for this really important discussion. This has been the day of climate caucus conversations, and it's nice to have another opportunity to talk about an important issue such as industrial decarbonization. As mentioned earlier, it's critical to addressing climate change and to securing the future of American innovation and global competitiveness. And also, I spend a lot of time, frankly, talking about how crucial it is to our own national security and to the security of the planet as well. For those of you who don't know me, my name is Chrissy Houlihan, and I represent Pennsylvania's 6th Congressional District, which is in the suburbs of Philadelphia and westward, inclusive of the city of Reading from the Reading Railroad, if you remember your Monopoly board. It also includes the city of Coatesville, which has a huge steel presence still to this moment in it. And so although this is sometimes referred to as the suburbs of Philadelphia, in many ways it's very relevant and germane to the conversation of today in terms of the industry that is there. Our community has that very proud industrial heritage, and we do remain an active hub for manufacturing. We touch everything, as I mentioned, from steel, but also to clean energy, medical technology as well, food processing, which was mentioned earlier too. But we've also, of course, personally experienced the very negative effects of climate change in our community, as recently as just a couple of years ago, when for the very first time ever, my major county, Chester County, was declared a federal state of emergency as a result of a hurricane that came through. So often industry activities and combating climate change seem to be framed as though they need to be in two different conversations, or at a minimum fundamentally at odds with one another. But I do genuinely believe that, as I mentioned earlier, fighting climate change is a must, and it has to continue to be. But at the same time, supporting our industries and the workers who power them is also equally essential, especially in places like Pennsylvania. And these priorities are not mutually exclusive. They do, however, require that we approach them with the mindset, which is the mindset of this particular meeting, of innovation and collaboration. Industries such as the steel industry, and mentioned the cement industry and chemicals as well, are critical to our successful infrastructure and our national security and to our global competitiveness. At the same time, they represent some of the most challenging sectors, as you mentioned, to decarbonize. And addressing these really hard to abate sectors requires both a commitment as well as bold and creative solutions to balance emissions reductions, economic security, and environmental protection as well. So this is really hard work, and welcome to this crazy place that is the U.S. House of Representatives and also the U.S. Senate as well. There is hope here in what you probably see from the outside as being a relatively dysfunctional group of people. What is that hope? The Bipartisan Climate Solutions Caucus. This is a group of more than 60 members, actually 66 to be specific, that are both Democrats and Republicans. It's what's called a Noah's Ark caucus. What that means is one Democrat needs to join with one Republican in order to be able to be accepted by the group. And this is an essential feature that allows us to follow through with our mission, which is to make sure that we are indeed advancing pragmatic and bipartisan approaches that address this issue of climate change with a durable and lasting lens to them. In the last year alone, this caucus has convened more than 26 meetings for members, as well as for their staffs. We have penned a variety of different letters advocating for climate and energy priorities, and we've even led groups to the bipartisan COP28, as well as 27, as well as 26, which sounds like it should be a no-brainer, but for the very first time ever, the bipartisan group of members of Congress came to COP several years ago to work together rather than to work at odds with one another. And so that's an evolution within just the last several years since I've been here. Director Avi Schultz and his team understand these kinds of goals. And I want to acknowledge the very critical role that you obviously play, the DOE plays in this effort, particularly through the Office of Industrial Decarbonization. And under your leadership, this office is obviously evidently driving forward programs and partnerships that will, I think, in a durable way, help industries adopt and transform technologies to make sure that we do indeed reduce emissions while still supporting, importantly, the bottom line of a company. This work, your work, is a testament to the idea that we can make industrial progress and climate action at the same time, and they must complement each other and not compete with one another. By prioritizing investment and prioritizing innovation and investing in these cutting-edge technologies, and by prioritizing collaborating across sectors, we are, in fact, developing and building a cleaner industrial sector that will remain strong and resilient and competitive. So the work of the DOE and leaders like you, Avi, have given us a clear path to achieving this really important balance. And I'm really proud to continue to support the efforts of the Congress, the men and women who stand representing us in this body, because this can't be accomplished without collaboration between government, between industry, and between researchers as well. And that's why gatherings and discussions like this are so important. So I really genuinely want to thank the panelists. I want to thank very much you for sharing your expertise and insights. I look forward very much to working with you in the future. The good news is I've been reelected, so I get the opportunity to excel, as my high school biology teacher would say with every test. Another opportunity to excel with all of you. So thank you very much. And with that, I'll turn it back over to you all. Thank you for having me.
Thank you, Representative Houlihan. Avi, if you'd like to come back up, I think there are a few questions here and there. I have one of my own, which is that obviously we are in a period of flux, to say the least. I'm wondering what you are hearing from the private sector about the kind of initiatives you've been pushing for the last several years. Private companies have to operate in a global world for most of these industrial processes. So they're going to be facing a world in which other countries and other regions are not necessarily moving in lockstep with us. So I'm interested in what you're hearing about how you see the next few years going in that complex world.
Sure. Thanks for the question. Everything we do as an applied research and development office within DOE is focused on thinking about market opportunities and what makes sense for the private sector to deploy. We're not interested in developing technologies that are going to sit on a shelf, but we're also not a company. We're not going to deploy or buy or sell those technologies to anybody, which means that everything we do in our office is very focused on what actually makes sense for the market. And as we work with our partners in the private sector, we are very fortunate that there are a large number of companies in the industrial sectors with which we work that have taken the vision to think about long-term strategies for themselves. When we think about the kinds of capital investments that are required in the industrial sector, these are not investments that rely on a 4 or 2 or even 8-year investment timeline. These are investments that require a strategy of decades, which means that there are a number of companies, some represented by folks on the panel here today, that have taken the vision to put together corporate strategies that are relatively insensitive to, I would say, short-term political considerations. Additionally to that, there are a number of different markets emerging globally, of which obviously, American companies participate in global marketplaces, whether that's from countries overseas or whether that's state-level markets that are being created in the US that are sending, or whether that's coming from consumers and organic demand directly from consumers, that is fairly clearly starting to put a quantifiable value on carbon footprint and the emissions footprint of products. So what we're really focused on in our office is understanding how we can help support private sector companies, not a small number of whom, by the way, as I mentioned in my remarks, are directly partners with us, either through our Better Plants or Better Climate Challenge, which are voluntary programs where companies have raised their hand to say, we are going to publicly commit to an energy or emissions reduction goal across our facilities. And they come to us in DOE to say, how can you help us? And that's really what we're focused on in our program, is developing both, of course, the commercial focused technical assistance, but also the next generation technology innovation that is going to help those companies. And again, just the last thing I'll say here is in addition to all those partners in our technical assistance programs, we clearly see, we get a resounding answer from industry that this work is valued because all of our work, all of our research, development, demonstration work requires industry cost share, whether at least 20%, if not up to 50% cost share for their products in many cases. That means that those companies are clearly economically valuing within their own corporate decision-making structures the work that we're doing to advance these technologies.
Thank you. If I can ask one more question before I get over to the panel and then the public. You talked about your strategy document. Do you have any idea when that is going to be public?
As soon as possible. The team has been working, as I mentioned, the team's been working for about 2 years on this. We held a workshop and released the request for information in May. We got a lot of great input through that convening process. And so the team has just been, you can imagine how busy the team has been in ingesting all that information and working on finalizing that document. I am very hopeful to be able to share that document in the extremely near future.
Excellent. That's good. That's the correct answer. I turn it over to my colleague. We have a question over there.
Yes, this is a question from a member of our online audience. It reads, what role can co-location of thermal intensive industries play in optimizing overall efficiency and allowing carbon capture for reuse and or sequestration?
Yeah, that's a great question. So I mentioned earlier the industrial heat shot that is a cross DOE effort to develop technologies for industrial process heating. The reason that is such a priority for DOE is because the industrial sector, so if you look at all of the greenhouse gas emissions from the industrial sector, just about half of all the emissions are due directly to combustion of fossil fuels or process heating applications. What that means is that, as we think about, what we laid out in our industrial decarbonization roadmap and how we think about the technologies that we're going to use to reduce industrial emissions, one of those pillars is energy efficiency. One of those critical pillars of only 4 that we identified is energy efficiency. And so we know that the first step to reducing the emissions is going to be to reduce the energy that's required. That's going to reduce the overall emissions. That's also going to reduce the capital investment needed for new energy technologies to provide that energy through alternative mechanisms. In the thermal area, what that means is something that the engineering community talks about as thermal process intensification. How do we go from facilities that were built up piecemeal and built up with an attitude towards thinking about individual unit processes? How do we redesign those facilities in a way to much more efficiently integrate the thermal processing, so that and develop technologies to more efficiently use that? So how do we develop technologies that, for example, can recover heat that's currently wasted, that's ejected to the environment? How do we do that cost effectively? How do we integrate that waste heat with existing processes on site at facilities, up to and including carbon capture, which may very well be required in a lot of these facilities? So it's a great question, and this is a critical and very active area of research for us in our program.
Do you work with any of the sort of AI partnerships and deep learning? I mean, I know there's a lot going on in biotech, but there's also a lot going on in chemistry or whatever.
Yeah, I think in DOE, we see AI as a really exciting enabling technology for a lot of our technologies that we're working on in DOE. In particular, technology solutions that are complex system optimizations, which we certainly have no shortage of as we think about the industrial sector, especially as we think about potentially grid integration challenges with demand or load flexibility to industrial sites, or more efficiently utilizing the grid and electric resources. We absolutely see AI as a critical technology to help us discover those new optimizations.
Yes, I mean, thanks for your comments. One of the pillars in the decarbonization roadmap is electrification. One of the big challenges with electrification industry is the cost of electricity in the U.S. relative to the cost of natural gas. You had mentioned the new thrust area, I think it was Apex, if I remember the
Epics.
Epics. Does that program look to improve the efficiency of electrical use so that the amount of electricity is decreased, low carbon, and the availability of that low carbon electricity is also increased, lowering those potential barriers? Can you talk a little bit more about this?
Yeah, absolutely. No, that's a great question. I mean, so yes, there's no question, right, that from a strict, energy cost perspective, a kilowatt hour of electricity is more expensive, at least right now today, significantly more so than a kilowatt hour of thermal energy from, say, natural gas combustion. But one of the really exciting things about electricity is that you don't need to be, I'll say, crude about how you use electricity, right? So if you're just using that electricity to, say, push it through a resistive heater and you generate heat, relatively naively or simplistically, yeah, it's probably going to be difficult for that to be cost competitive just on its face with say, conventional combustion. But the really exciting thing about electrification is that it opens up a whole new universe of technology. So just in heating, for example, you can think about getting much smarter with heating. For example, if you're, say, in a baking facility, you can use IR heaters, so you can transmit all of that energy that you're using through your electric resource and convert that, instead of just kind of crudely heating a resistive heater that then transfers that heat, say convectively through the air. You can use special kinds of coatings so that all of that energy gets converted just into IR radiation, which delivers precisely the kind of heat you need to, for example, get the right texture on a tortilla or on a loaf of bread. There are other technologies for other specific applications. So as we think about other kinds of, say, metal heating technologies, we can think about induction or laser or plasma heating that can much more efficiently deliver that heat than conventional, either, again, electric resistive heating or conventional fossil fuel combustion. So we think there's some exciting opportunities to actually improve the efficiency by using a more valuable energy resource such as electricity. Additionally, we see a lot of opportunities for electric heating to provide additional actual operational flexibility and operational value to a facility. By using electrical infrastructure, you potentially have opportunities to, for example, reduce transient or ramping restrictions on operations of equipment, which again allow you to actually realize real investment value for facilities, whether that's giving them more flexibility on how they can operate, whether that allows them to meet lower, work with their utilities to negotiate lower time of use tariffs on when clean energy or low cost energy is more available. And specifically, one of the opportunities that we really see for that is using thermal energy storage or other energy or electrical energy storage to really specifically dial in those opportunities. So we're using the lowest possible cost electricity that we can at an industrial facility at any given moment. So we see a lot of really exciting opportunities there.
Right.
Thank you very much.
Thank you.
Dr. Schultz, really appreciate it. There was a lot in there. It's going to take me a while to fully integrate it, as you might say. I think we'll just introduce our panelists very briefly. We have an excellent panel here. Sharon Nolan, to my left, is Eastman's Global Natural Resource Manager and Chair of DOE's Industrial Tech Innovation Advisory Committee. As I mentioned, thank you for being here. Ed Reiter is formerly head of industrial programs at ACEE and a longtime executive at Dow Chemicals. He brings a deep knowledge from that history, that is for sure. He also headed ITIF's Center for Clean Energy Innovation. So thank you for that. And we have Sasha Stashwick, Director of Federal Affairs for Antora Energy, and she is going to explain to us what Antora Energy is and does. So perhaps, Sharon, you'd like to go first?
Yes. Sorry. Yeah, just to start with a few comments, I would like to say Eastman is a materials innovation company. We are one of the beneficiaries of the DOE grants from OSED that Bobby talked about. And I think that is important to think about incentives. You know, when we think about incentives, just like he said, you know, industry is putting up a lot of the money as well. For the particular project that we have, we're putting in more than double the DOE grant. And so it benefits Eastman. It also benefits others who may want to adopt the battery technology that we're going to be demonstrating at full scale. So if you, in general, look at incentives, they often create jobs and create domestic opportunities. Whereas if you think of very heavy regulations, that often decreases investment and drives things offshore. So we believe there's a really critical role to play for investments in clean energy. Another comment I wanted to make is that regulations are one of the challenges that industry, I think, across all sectors experiences. Like was mentioned earlier, these investments of large capital projects take quite a bit of time, you know, from the time to decide to do the project. It may go through a pilot phase, detailed design phase. It can literally take years to do these projects. And when we don't have insight into where the regulations are headed, that really causes concerns for companies in terms of how are they going to make their investments in a very uncertain future. So I think streamlining regulations to make them more efficient, as well as giving industry more insight as to where regulations are headed, would be extremely beneficial. Another thing that I want to say is that, you know, we talk a lot about regulations and policy, but some things happen in spite of, or maybe beside those things. You know, we see customers are really demanding products with lower carbon footprints, products that generate less waste. And so those are things that are going to drive innovation in this space, I think, regardless of policy. And then finally, I wanted to echo obvious comments about the technologies that are needed. I think we've seen that no one solution fits everything. Even within our own company, we're seeing that different sites are going to require different solutions. It's not even one solution for Eastman as a whole. And I think energy intensive industries that need not only electricity, but thermal heat are some of the ones that are going to be most challenged to decarbonize. And so we're really looking forward to what DOE is doing in terms of their research and development to help us understand what new technologies are possible and to build that into our long-term greenhouse gas reduction plans.
Thank you.
Okay, well, thanks to Robin and ITIF for organizing this discussion topic. I'll provide a little bit of perspective here. In 1979, the U.S. manufacturing employed 20 million workers. Today it's about 12. The manufacturing contribution to GDP in 1979 was around 20%. Today it's 11%. We're about 2.35 trillion direct. I think Dr. Schultz had mentioned combined indirect and direct of over $4 trillion of impact. And manufacturing is still the sector with the highest economic multiplier, meaning the impact cascade in products and services is a really large opportunity. A couple of thoughts on decarbonization and how it can boost competitiveness. What are the rationales, the business case, if you would, for decarbonization? One, it can provide spurring of revitalization of processes, infrastructure, and supply chains. Many of the manufacturing clusters are there because of advantaged infrastructure. And this renewal is something that really can occur at those clusters with infrastructure. But the U.S. is poised to recapture a large portion of the capital manufacture of the global manufacturing. Carbonization that presents the biggest opportunity in generations to transform processes to be more efficient, higher value return, supply chain resilient, and sustainable. $4.6 trillion in global trade is expected to shift in the next 5 years, according to an analysis from McKinsey. With an effective manufacturing transformation, the U.S. could boost manufacturing's GDP contribution some $270 to $460 billion, while adding over 1.5 million jobs. Second, enhancing the competitive position of the U.S. sectors helps those sectors that are advantaged already in making low carbon products. So a couple of examples here. The U.S. has 3 times the percentage of steel made from electric arc furnaces versus the global average. This gives a carbon intensity half that of China for many steel products. Hydrocarbon feedstocks, such as in the chemical industry where I have spent my career, having carbon intensity half that of what you see in China, 40% lower than in the European Union. Hence, those inherent advantages is something that we should take advantage of for those industries that already produce low carbon products. Decarbonization can also allow U.S. businesses to enter new and adjacent value pools, securing early demand for low carbon offerings while benefiting from low cost financing. Third, being a lever for increasing innovation. Dr. Schultz mentioned innovation is at the core of where industry is and how it must compete. It can also incorporate leveraging resources, collaboration, and attracting investment. To reach net zero greenhouse gas by 2050, some $150 trillion will be needed, according to an analysis from Brookfield. Some $1.8 trillion was invested in 2023, with private money accounting for more than 40%. Companies are already integrating cost and carbon reductions, seeing up to 40% CO2 reductions, 15% improvement in financial performance for a McKinsey study. Hence, the economics are there both for financial performance as well as carbon reduction at the same time. And one can look for additional reductions in other pollutants, SOx, NOx, VOCs, particulates. As one looks at the opportunity for CO2 reductions, it's important to look for other reductions at the same time. This investment can also free up cash for investment in new opportunities. That's very important to manufacturing. And lastly, mitigating operational and supply chain risk. Manufacturing just doesn't exist in carefully controlled environments. It inputs in entire supply chains are subject to the ripple effects of natural disasters. It's really important to mitigate those environmental risks. So some actions are needed, including reducing the risk and giving a durable investment horizon with demand pull and supply pull policies. Relentlessly slashing the price of low carbon options by innovation, non-energy benefits at scale, supporting the investment in innovation and revitalizing key industries, hardening infrastructure, expanding low carbon delivery, while also vastly improving efficiency and resilience. And lastly, leading on developing systems, methods, and metrics to quantify and report carbon intensity in products.
Thank you, Ed.
Hi, everyone. So as Robin said, I think I'm going to use my time to maybe introduce Antora on the assumption that you've never heard of us and you don't. I just wanted to explain what we do. So I guess I'm here as a representative of one of the technology solution providers that are being kind of discussed in this context. So we heard Dr. Schultz mention thermal energy storage as helping to really dial in those opportunities to use the lowest cost electricity to power industrial facilities at any moment. Industry doesn't shut off and on. They need energy typically on a continuous basis on demand 24/7. And so we are a thermal energy storage provider. We manufacture thermal batteries here in the United States for the industrial sector. And maybe I can just unpack a little bit what a thermal battery is and the sort of value proposition here in terms of that cost competitiveness. So thermal batteries essentially sit on the nexus of the power sector and the industrial sector, and I would say deliver really important cost and security and competitiveness benefits on both sides of that equation. So we are essentially the most flexible load on the grid. Thermal batteries charge really flexibly, really quickly, and we are able to charge using the lowest value hours of the day of electricity. So grid operators can essentially turn us on and off on demand, and we can charge during the 8 lowest cost and sort of again lowest values hours of any 24-hour cycle. So these are times of the day when you have a lot of sun or a lot of wind, and you see energy technologies like wind and solar pushing electricity prices down to near zero or even negative. Right now, a lot of that energy is just being wasted. Thermal batteries can soak up those clean, cheap electrons and actually put them to good use, powering the local economy. And we can do that without adding costs to the system, without adding transmission costs, without adding other distribution costs. And so in doing that, we're actually reducing costs for all grid-connected consumers. And then on the other side of the equation, we're passing on those benefits to our industrial customers. Industrial customers, again, need a lot of energy, as Dr. Schultz described, and they need it on a continuous basis. So we are a long duration storage technology. I think folks are typically knowledgeable about electric batteries, which can be more short duration. Our batteries are can store energy for tens of hours into the multi-day time frame, and we can do that really efficiently. So we're charging with electricity, and we're able to store that energy in the form of heat inside our batteries. And then the benefit is that our industrial customers can then utilize that heat on demand to run their processes, whether it's a food manufacturer or a chemicals plant, and so on. And I'll just say that one of the key breakthroughs, one of the reasons that we're able to do this at Antora is because our storage medium is solid carbon. It's kind of like the graphite in your number 2 pencil. It's a really earth abundant material, and it can get up to very, very high temperatures, and it's very good at storing energy. So we can do this very efficiently, and we can avoid some of the, let's say, challenges associated with some of the critical mineral sourcing and other sourcing that's needed for other types of batteries. The supply chains of graphite, of the carbon that we need are, available here in the United States, including in places like Pennsylvania, where Representative Houlihan is from. And so that's kind of a little bit about what we do and the value proposition. This is all about, I think, helping industry be more efficient, more competitive, and also helping to secure our energy infrastructure at the same time. And the only other thing I'll say is that we are manufacturing our batteries for our first commercial projects right at this moment. Just last week, I was out in California at our factories. I happened to be on the phone with Ed. He heard all the banging, the banging and the welding and the swirling. It's very exciting. That's our first factory out in San Jose. And we are in the process of scouting a location for our second factory, which we intend to be 10x the size of our first, employing roughly 1,000 people. The policy environment that we enter into is going to be a big part of the decision about when we make that investment in a second factory. So that's the story of Ventura, and hopefully, in the context that the other speakers have provided, we're sort of emblematic of the technology solution providers that are kind of quintessential American innovation and a big part of the industrial electrification and decarbonization value proposition.
Thank you all. I have a couple of questions before throwing it. The first one is actually Sasha. Do you see your technology as a way to essentially electrify industrial heat processing? In fact, your technology, I mean, one can imagine your technology as a complement or as a competitor for fossil fuels. Would you care to elaborate on that?
Our technology is a drop-in alternative to the incumbent process heating system. And the idea is that we're trying to make use of essentially the cheapest form of energy on Earth. Where you have right now excess wind and solar capacity, that is where you see prices that low, really at zero. This is a feature, it's not a bug of renewables deployment. Right now, that energy is being wasted. So this is a technology that, again, can sort of fill those valleys sort of in on the grid. And importantly, I would say, pass those savings through to the industrial sector. Sure. In places in the country where the alternative is to build expensive transmission infrastructure to move those electrons, out of that region, this is a technology that can keep that energy powering the local economy. In the windy Midwest, you have a lot of industrial manufacturing, and you have a lot of this energy being wasted at the moment. So it's a real breakthrough in being able to bridge those two.
Yeah, so I wanted to say our demonstration project is a thermal battery. And so one of the advantages we see, in addition to what Sasha was talking about, is we have customers who want greener products. And so that enables us to take advantage of, in our case, solar, but it could be wind as well. Those aren't available 24 hours a day like electricity is. And so it allows us to really be able to utilize solar in a way that we can get the heat from that on a 24/7 basis that we could not use solar panels directly. So that's the other advantage I see for industries.
Can I add one more thing? So
Sure.
I don't, not to speak for Eastman, just an archetypal industrial plant needs that energy 24/7, but it can't pay for electricity 24/7. The real value here, just to put a finer point on it, is that the thermal battery is what allows you to match take energy that's being produced at times of the day when it's not useful to a lot of people, and match it up with the times of day when it is useful to the industrial facility, and do it at that very, very low cost. Otherwise, sort of direct electrification becomes quite expensive, as I believe compared to gas prices. But that's what allows you to sort of match up those loads at that low cost.
Yeah, so I'll add to those points by saying that the thermal batteries not only can help with electricity, but they can also help with the heat from fossil fuels as well. So they provide a buffer opportunity to capture whatever energy you can capture, and then to give it back when you need it. The second thing I'll mention is that can help with demand response across industries. And across the power grid, helping to provide power when it's needed and to hold it in reserve when it's not needed. And that should help with the efficiency across the system.
I wonder if we can open the floor in a second. I do just wonder if any of you are thinking about the export of competitive technologies. It seems to me we are perhaps thinking, we have such a huge market here. It's so enormous, it's so dominant. We sometimes forget about the rest of the world. And I think when we're talking about US competitiveness, there's always a trade dimension. And I wonder if any of you have anything you want to say about that, or whether I'm just winding down a dark alley.
Yeah, it's a good question. Trade is a big part of this dynamic. And there's several different sides of that. On one side, it's really going to take cooperation to develop some of the newer technologies because of the fact that they are so expensive. And one of our great potential collaborators are global partners. But you also have to consider that some technologies are best for different parts or regions of the world. And so in some ways, it's okay to give away technology because maybe it's not as appropriate in your area of the world. Take, for example, the area of electric crackers. So electric crackers, so if you take ethane and you crack it to ethylene, that's the way that you get many polymers, such as polyethylene. And a number of international companies are collaborating in Europe on electric crackers. Why? Well, because of the fact that the cost of electricity there compared to natural gas is lower because natural gas is super expensive in Europe. And they also have some advantages in Europe for using that type of electricity for crackers. So you'll see a number of collaborations, even with companies that are based in the US, on crackers in Europe that are based on electricity. It may not be as appropriate for that technology here because of the fact that we have really high amounts of natural gas liquids, and that gives a richer hydrogen stream in a cracker for which we have other options. So I guess my point to your question, Robin, is that there's areas of great collaboration with organizations that can be our competitors, but some of the technologies are more appropriate for their area of the world than they are for ours.
Yes, I think I'd just add a quick point to that. ITIF's focus is on climate as a global problem. We don't believe that we can solve the climate crisis unless it is solved in India, in China, in Indonesia, in Nigeria, in the countries that are electrifying and urbanizing rapidly. That is where emissions are growing, and that's likely to continue. So we have to think about climate change and climate solutions from the perspectives of those countries. And that has a couple of dimensions to it. These are not high-income countries. They are not countries which are going to subsidize their way out of the climate crisis. They will not pay the green tax that richer countries might or might not pay. So we have to find technologies that are price competitive. There's really no solution there. We must do that. And much of the work Avi is doing and that other people in the US are doing is directed towards that. The second dimension is something that Ed said, which reminded me that the world in these countries is not the same as the world of energy here. Here, everybody working on green technology faces the problem of cheap natural gas. Gas is cheap, it's the benchmark, it's the existing resource. If you go to India, gas is not cheap, coal is cheap. We have a different set of problems, and perhaps a different set of solutions. So it's important to keep that international, global dimension right at the front of the thinking. Anyway, that's the ITIF position on this. Can I open the floor to questions? Oh, all kinds of questions.
I just wanted to pull on that thread a little bit more, Robin. I saw a recent third way report that US had 60% of carbon capture capacity globally. And with Canada kind of shifting towards that carbon tax, EU CBAM, I think that that is an important position to kind of think through. I know we're all thinking about whether that will be a provision maintained in the IRA, and so I'm just curious what some of your thoughts are here on the panel. There is demonstrated bipartisan support for it, but just what are some from your different industry perspectives?
Any takers on that?
Okay. Yeah, it's a good question. The U.S. is advantaged in the area of carbon capture and storage, as it's been practiced for more than 40 years in the U.S. in the oil and gas space. So we have the technology, we have the reservoirs and places where you would put the CO2, and we have the pipeline infrastructure in certain parts of the U.S. Industry can take advantage of that for various processes. For example, hydrogen, so-called blue hydrogen, where you take the CO2 and you would put it in the ground some other way, sequester, is an early opportunity for cleaner hydrogen than that which is used today. Industry is starting to move in that direction. Blue hydrogen, you see projects on the Gulf Coast and elsewhere taking steps in that direction. That's a precursor, in my view, to green hydrogen, which is that from electrolysis and that it will establish the market. Back to carbon capture, other regions of the world don't have that advantage of having demonstrated carbon capture and storage, nor the pipeline infrastructure, nor the policies to support it. Germany, for example, for a long time has precluded CCUS as one of the options. They're going back on that, I think, but that is an opportunity where U.S. has some advantages in this space, and that's an opportunity for continuity in policies, even in the present switch.
Yeah.
Question for us, Sasha. And I've heard great things about Antura. I didn't make the connection, but isn't this the technology that DOD is looking at for enrolled in a study of Antura's ability through long duration energy storage to allow military bases to get away from backup diesel generators? You may not be familiar with that, but
Very vaguely.
Okay.
I think that there are applications like that.
Anyway, my question is, you have gotten, Antora has gotten funding from FERC, has it not? Yeah. So since we're entering an era of denial of climate and denial of the role of government in solving climate, maybe you could speak to how RPD funding and maybe funding from other parts of DOE has helped or get to where it is.
Yeah, so we did receive an ARPA-E scale-up grant earlier this year. It's for, I didn't really speak about this, I kind of focused on our core power to heat battery module, but we actually have a pre-commercial technology that is a combined heat and power module, which is able to discharge energy both as heat and as electricity. And so that's what the ARPA-E scale-up grant was, to help us commercialize that technology. But I think just zooming out, yes, Antora it has kind of come up through DOE's I don't know, the sort of maturation of sort of across several DOE offices, and while the business wasn't built, I would say, with IRA incentives or sort of DOE investments kind of built into the plan, certainly they're really material and important. And I think the more important point is that it makes sense to invest in American innovation, these really cross-cutting technologies that can help our industrial sector be globally dominant and competitive with our competitors, whether it's in China or in Europe or elsewhere. And that doing this in fits and starts is really suboptimal, right? Because companies like ours, need to be able to make investments, make decisions, and we want, I'm sort of using Antora as an example, but we want, many Antoras to have that policy and certainty to be able to continue on this path. There's a lot of benefits in terms of manufacturing base and jobs, our ability to compete globally that come out of that. And our competitors are, China wants to be globally dominant in storage too, right? So if we kind of cede that ground, it's really hard to kind of get it back, right? So pulling away from these types of investments, I think, would come at a real economic cost. Maybe I'll stop there and others can their thoughts.
Well, I think government funding helps in lots of aspects. When I think about the project that we're doing on recycled PET, it's any benefit we get from a financial standpoint allows us to move forward. And it also allowed us to make a product because it can be a greener product that is more desired by some of our customers. And, when you look at that project in particular, the things that have to come together to make it happen, I think there's multiple dimensions. Part of it is the investment, but we also need the available infrastructure to be there. And so, I think that's something else DOE is looking at is how do we maintain the integrity of the grid and make sure it's sufficient, particularly when you look at increased electrification. You also have to have, asset or technologies that are ready to implement. And so, we need to drive innovation. One thing I like to say is at Eastman, I think sustainability is driving innovation in the products that we make. And then finally, we have to have policy support and demand for the low carbon product. We cannot decarbonize and create a new product if nobody wants that product. And so we have to have the customer there willing to take it. And that was another thing that contributed to our RPET project in Texas is we have an agreement with PepsiCo. They want that green PET. And so all of those things come together to make for a successful project.
Given that Dorothy raised sort of national security issues, I would raise one here too. We're now actually entering a new era where national security and economic competition are so deeply intertwined that we can't pry them apart. So we have to ask ourselves as a society, what parts of our economy, and it's not just consumer goods, right? What parts of our economy are we comfortable ceding to other countries? And what parts are fine? They're you go back to, potato chips and microchips, for those of you who've been around as long as I have. The question, what is a strategic good, is one that we have not really begun to answer, I don't think. And, you can ask yourself, would you be comfortable if the key components on the grid, for example, were made in China? Maybe not. Korea? Maybe. UK? Probably. We have different answers for different folks, and that is not the sort of world trade regime that we thought we were living in. So that applies here very directly, because as Sasha said, well, we want storage on our grid. We're going to need storage in order to decarbonize. Where do those batteries come from? What kind of control do we want? Do we want Chinese-made batteries made in Georgia? I don't know, probably better than made in Shanghai, but is that what we want? So these are really big open questions that are being forced open by the transformation of our green, of the energy side of our economy. So. And there aren't easy answers. So I think that's just a sort of side comment, but anybody can come back on that. Or are there further questions? Stuart, you had a question. Sorry, a little rant there.
Wondering, with the new Congress coming in, are you able to name one or two top policy priorities that you would want to pass along in terms of kind of competitiveness and decarbonization?
Start. Okay. I'll talk about three. The first is that there are existing programs. They've been name checked here. Many of them are being administered by DOE, but some of them are being administered through states. And these are where we are investing in really high quality projects to demonstrate new technologies, deploy them commercially, and bring them down the cost curve. Because to Dr. Schultz's point, if a technology is not cost competitive, it essentially it exists, but it's not useful, right? So ensuring that we keep investing those funds, that we safeguard those funds, I think that's a top priority. And it's not just happening at the federal level. I would say that one of the highest impact things that's happening for industrial competitiveness right now is the RISE PA program in Pennsylvania. We have Representative Willingham here. RISE is nearly $400 million. It's with the state of Pennsylvania, and it's being directly invested in industrial decarbonization, but I would say it's industrial transformation and competitiveness, right? Really high impact program. We want to make those investments. Why wouldn't we want to make those investments to ensure that, it is industrial manufacturing here in the United States that has that position, or maintains that position of primacy and keeps that momentum going. So I would say those direct investments are a really top priority. The 45X advanced manufacturing tax credit from the Inflation Reduction Act supports innovation and technologies that are manufactured here in the United States, right? These are really high quality jobs. These are factories all over the country in red, blue, and purple states. And there seems to be real bipartisan support for that tax credit as a result. We ought to be making those investments. And then finally, I'd say kind of parochially, I think for thermal energy storage and thermal batteries, again, electricity market reform so that we can access those really low value, low cost electrons, clean electrons at times of the day when they are in excess and they're being curtailed and they're actually not valuable to the broader economy. We can turn them around and make them valuable to local industry, but we actually need access to wholesale electricity markets. Or we need tariffs that are designed for highly flexible industrial loads like ours. And that's actually a non-spending policy, right? That sort of market reform is a regulatory reform proposition that really unlock scale in terms of getting more thermal batteries, not just in niche markets, but actually pretty much across the country. So those are my three.
I'll just build on the first one there that you mentioned, which is electricity reform. I think that's also super important. There's over 3,000 utilities in the U.S. That fight with the regulators on how electricity flows eventually to end consumers and how the pricing is set and who has access to various portions of the value chain. It's been said that thermal energy storage has to fight for a greater portion of that value chain to be recognized, really as something that can contribute strongly to the value part of the equation. And I think that type of electricity reform is really important. Second, I'll note that carbon border adjustment mechanisms is something that's already going to be starting the wheels in 2026. Being implemented in Europe. And I think the response to that is something that the U.S. will also have to consider. Part of that is continuing the work that's already going on at DOE, NIST, on carbon standards and following the carbon intensity in different products through various different protocols. And I think being able to follow the carbon through supply chains is also important. So estimation of the carbon intensity is something that people have been doing, but there are companies that are starting to quantify the carbon intensity in products. Williams is working with context labs, for example, to quantify the carbon throughout the supply chain in various hydrocarbon streams. And they're doing that through actual use of data from the facilities themselves. So I think that's an area where we really need to come up to speed. It's an area where policies need to support the U.S. becoming a leader in understanding what's the carbon intensity of our products. How do we communicate that to customers? And how do we use that for competitive advantage?
Building again on some of what Sasha said, when you think about CBAM and other things like that, it's really important for us to drive innovation within our economy. We don't have a carbon tax at this point. We might in the future. Global companies are having to deal with it no matter what. And the companies that are ready to adapt to that are going to be the winners, I believe, in the long term. So one thing I think we specifically need to do is make sure we protect the OSID funding. I've talked about Eastman getting one of those, but there were, I believe, 30 some other companies that got those as well. And all of those companies have committed resources, people, money, effort, to get to this point. And so to have the rug pulled out from under you, it's not going to encourage American innovation. And I think that's something we really strongly need to do. The second thing I would mention is there is concern about the grid. We have an old electrical grid, and it's going to be more and more important that we make sure we maintain the integrity of it. And I think that's a place where policy is needed and infrastructure money is needed. And then a little off the subject, but at Eastman, we do talk about it's not just decarbonization. There's also a global plastic waste crisis. And so, some of the technologies we're working on deal with both. And so I think policies around recycling of materials would be very beneficial, not just for plastics, but you look at recycling rates in Europe and how they're able to reuse so much material. And when we can reuse material, that does reduce our carbon footprint and our energy requirements. So I think we need to continue to focus on that as well.
Thank you all. Do you have a question from over there?
Just one more if we have time. Question from the audience online. How do we ensure we don't increase other atmospheric emissions and waste streams while focusing on decarbonization? Leave that open to.
Not me.
Well, as I mentioned earlier, it's important to consider all of the emissions. We talked about emissions to air, but it's also important to consider emissions to land and water at the same time. Energy and water are connected. It takes water to produce energy. It takes energy to move around water. And so I think looking at the emissions across the entire range is important to avoid additional emissions in other areas and to avoid unintended consequences. And Director Schultz mentioned as well, it's important to also decrease the impact to neighboring communities as well at the same time. We have to do it all at the same time. We have new tools to be able to do that. We have new focus to help us along that path.
I'd like to perhaps conclude with one thought that DOE and DOE's programs and other energy programs from the federal government are clearly going to be under immense stress. That's putting it mildly. It's going to be really important for the people working in this area and who believe in these programs to do two things. One, of course, is to figure out which programs are the most important. There are going to be programs on a chopping block. It's inevitable. We better figure out, where the light bulbs are and which ones need to get launched. But there's also something I think I'd asked for from DOE, which is I think DOE has to work harder, much harder, to be transparent about the outcomes of its program. It has to focus on outcome metrics, and publish them regularly. For example, we are now 2 years into the $8 billion hydrogen hubs program. Nobody at DOE has, as far as I know, really explained why we picked the hubs we did, what those hubs are actually committing to do in terms of milestones, or even who the participants are. Everything is coming from the hub side. And this is a major investment from DOE on clean energy. We need to know what it's up to. And I think this is a general thing. DOE used to be a science research agency, and it was used to working within the environment of scientists, and you do peer review, and the peer review gives you a guarantee, and then you do the work, and sometimes it works and sometimes it doesn't. That's fine. That's what science is about. But large application programs are different, and we need to have better vision into what DOE is trying to do so that we can understand, okay, this didn't work. That's fine. But we need to get past the veil of silence, if you like, that DOE, for historical reasons, has always done. And I'm not knocking it for that, but we're in a new world now. If you want to persuade Republicans that what you're doing is valuable, you need to show them. So that's what I'm hoping for Christmas. Oh, can I say Christmas? Okay, that's now okay. I think we're good. Thank you very much, Dr. Schultz. Thank you very much to my panelists. This was a beautiful event. So thanks very much.